Hello everyone, my name is Samirul Hazibin Roslin, and for today's experiment we'll be doing tensile test. The objective of this test is to obtain the general understanding of how different materials and cross-section behave under unaxial tensile loading. The second objective is to determine stress-strain relationship and compare mechanical/material properties of various materials and cross-section. The third objective is to obtain the mechanical properties, the modulus of elasticity, the yield stress, the ultimate stress, the fracture stress, and lastly, the ductility ratio. We will be using two specimens for today. The first one is rubber, and the second specimen is plastic. And let's not forget about our safety gear, which is glove and safety glass. First, wear your gears. Take the specimen and then pull it. First of all, measure the specimen. After you stretch it a bit, measure it again to see the difference. Alright, I got it. And then stretch it until it breaks. Stretch it slowly.
For discussion, we have 5 questions for the total. So for the first discussion is compare and discuss the result in table 4 to reference value and comment on the possible reason for discrepancies obtained for a test specimen. So my answer is, I will show my answer in the screen. Move to the next discussion is compare and discuss the similarities and differences on mechanical and material properties for the material tested. So I will show my answer in the screen again. Move to the third discussion is distinguish between yield point and yield strength on a stress and strain curve, which give the more accurate indication of a material fitness for a particular tensile application. So again, I will show my answer in this screen. So for the next discussion, which is the fourth discussion, is distinguish between the proportional limit and the elastic limit for each material, which is more important indicator for a material mechanical behavior. So once again, I will show my answer in this screen again. So for the last discussion, which is the final discussion, what are the advantages of a strain stress diagram over a load vs deformation diagram for showing the result of a test? So like usual, I will show my answer in this screen again. In conclusion, the reaction of the test specimen when an axial tensile loading is applied with various material as well as its cross section. It is found that each material and its cross section possesses different mechanical properties such as modulus of elasticity, yield stress, ultimate stress, yield strength, fracture stress, and ductility ratio.
So we go to the discussion. So the first one is compare and discuss the result in table 4 to reference value and comment possible discretion obtained for a tested specimen. So basically there are three, which is steel, which is 200 gigapascal, brass is 97 gigapascal, and aluminum is 69 gigapascal. So based on the three, basically based on the reference value that is given this, the experiment is repeatedly and it can cause many errors. The first one is because of the experiment is being done many times, so it will produce many values that we not know that whether those value is accurate or not. When we do this experiment method like this, we will get the values as same like we get, which is not accurate. Secondly, the mistake when we do during the experiment such as in test is probe or not accuracy. So based on that, we have to make sure that when we do some experiment, we have to use a good apparatus. So the second one is compare and discuss the stability and differences in mechanical properties of the materials tested. So there are three different of material, which is steel and brass and aluminum. So we go first to the difference. The first one is steel, which is good conductivity and toughness, soft and weak and low hardenability. Brass is good corrosion resistant, ductile and good thermal conductivity. And the last one is aluminum, which is high strength, good electrical conductivity and good corrosion resistance. So the similarity of the three material is all relatively strong and offer a high level of protection against corrosion. So the third question is distinguish between yield point and yield strength of the stress strain diagram, which give the most accurate indication of material fitness for a particular tensile application. So we go to the yield point. Yield point is indicates the limit of elastic behavior and the beginning plastic behavior, and the material will deform elastically and will return to original shape when the applied stress is removed. So while the yield strength is deform plastically, whereas yield point in the point where non-linear deformation begins. And lastly is the amount of energy induced in the material to overcome or to avoid yield. So Yield point is the very suitable because it is accurate and indicate the limit. So number 4 is distinguish between the proportional limit and the elastic limit for each material, which the more important indicator of the material's mechanical behavior. So the first one is proportional limit, which is the elastic deformation region transition into a non-linear plastic deformation and region, while the elastic limit is maximum stress that its material can withstand before the permanent deformation, and it is the highest limit of the material before the plastic deformation of the material can occur. So elastic limit is very important because it can deform the plastic before and is directly proportional to the strain. So the last question is, what is the advantages of the stress strain diagram over a load diagram for showing the results of the test? So the advantage of the stress strain diagram is where provide design engineer with a long list of important parameters needed for application design, and also can be normal shear or mixture, also can be unaxial, biaxial or multi-axial, even change with time. So meanwhile, for the load deformation, it is include indicating the important effect on dynamic concrete strength due to the varying strain rate, and the diagram actually not even used by some engineers because lack of information. So what is the conclusion for the experiment? So base of the experiment, the objective of this experiment is to increase the general understanding related to how different materials and cross-sectional react under the unaxial tensile loading is achieved. So by doing experiment repeatedly, we can achieve that. So next, to prove the strain relationship and compare the mechanical of the properties of multiple material and cross section is achieved. By using the data given, I can calculate it to prove that can compare the mechanical properties of each material. So lastly, to obtain the mechanical properties, we are the modulus of elasticity, the yield stress, the ultimate stress, the fracture stress, and the ductility ratio is achieved. So based on the result given, I can see those mechanical properties and I can conclude. So while doing experiment, I get that when we want to make the tensile test, we need more info or requirement so that we can calculate the result. Tensile test taught me that when the tensile test is, we want to determine how strong the material that we want to test. So also for the discussion tensile test that we made, based on the test that we made, we can see the difference, which we can see the which diagram that is suitable, mechanical properties, and much more. So I can conclude that tensile test is very important.
Discussion 1. Compare and discuss the result in Table 4 to reference values and comment on the possible reason for discrepancy obtained for a test specimen. So this is the Table 4. To clarify things, the result we achieve in this experiment might not be accurate because of a few factors such as misalignment, slippery grip, wrong measurement, human careless mistakes, and wrong decimal. By recording wrong measurement, it could lead to serious damage to the calculation afterward, which are needed at the end of the experiment. This is why some of the results is big and some of the result is too small. Aluminium has the highest proportional at limit stress. This means that aluminium has the greatest stress that is directly proportional to strain. The next is nominal and actual fracture stress when nominal is lower than actual stress. Actual, also known as true fracture stress. Fracture stress is the load at fracture where it gets divided. True fracture stress is the load at fracture where it gets divided by the cross-sectional area. In this table, steel has the highest value. Reduction in area. To calculate reduction in area, use the formula of reduction in area is equal to final cross-sectional area minus initial cross-sectional area divided by initial cross-sectional area times 100%. By using this formula, aluminium has the highest reduction in area. Aluminium too has the highest elongation percentage, which also means that aluminium has higher ductile material. On the other hand, the lowest is steel, which is prone to ductile material. The similarity: steel, brass, and aluminium share the same mechanical properties, which is they are strong and high corrosion resistant. But steel is strongest, while brass is the most conductive and aluminium is the lightest. Heel point indicates the limit of elastic behavior and the starting of plastic behavior. On the other hand, stress, which starts to deform to plastic, are the definition for yield strength, indication of a material's fitness for a particular tensile application, because it starts from the beginning where we can identify the tensile force required to deform specimen. Proportional limit is the point of the stress-strain curve where the stress in the material is no longer linearly proportional to the strain. Beyond this point, the law of Hooke is no longer applied. Elastic limit is the stress-strain curve, which the material does not return to the original shape when the load is removed due to plastic deformation. The difference between these two is elastic limit defined as the point where the material still remains in its behavior, which is elastic, while stress and strain is both directly proportional is the definition of the proportional limit. Therefore, proportional limit is more important than elastic limit as an indicator because it can determine the greatest strength of the specimen. Many properties can be obtained from stress and strain diagram. For example, one could obtain ultimate strength, fracture point, yield strength, modulus of elasticity, which is the slope of the graph, type of material, whether it's brittle or ductile, which is also can be found through the ductility ratio. Plus, calculation for safety can be made. In conclusion, all of the objective has been achieved, which is to obtain a general idea on how different materials and cross-sectionals behave under axial tensile loading, determine the stress-strain relationship, and compare mechanical properties of various materials and cross-section, and finally to obtain the mechanical properties, which is the modulus of the elasticity, the yield stress, the ultimate stress, the fracture stress, and the ductility ratio. The recorded data in the report might not be accurate because of this experiment is process of trial and error. Therefore, a lot of factors that could affect the data. For example, misalignment, human careless mistake, wrong decimal, wrong measurement, and might be the fault at the apparatus. From this experiment, I have learned a lot, which is this experiment is quite difficult because there is a lot of formula to calculate the value, and each of the formula will give a different value. All of all, I have learned a lot from this experiment. Thank you for watching.